Now, in this lecture, we'll find the radius of a circle. You can see in the drawing we have a circle, and inside the circle we have a square in the red color. The center of the circle is at point O, and actually we will name the point of this point, we will name it as point M, and also we will name this point point N. Okay, that will be point N. So actually we know that line segment MC equals to 6 units. And the line segment AN equals to 3 units. And we want to find out the radius of this circle. Okay, let's define line segment OM as X. Okay, OM equals to 6 units. OM equals to X units. And okay, OM, line segment OM equals to X or X units. And we will define line segment ON as Y. Okay, line segment ON is defined as Y, or line segment ON equals to Y. Okay, and first of all, MC equals to 6 units, AN or NA equals to 3 units, and OM, line segment OM is defined as X, and line segment ON is defined as Y. Okay? But we actually know that OC is the radius of the circle, and OA is also the radius of the circle, so we can say that OC equals to OA. Both of them are radiuses of this circle. So OC equals to OA. Okay, so that will be our first equation. OC, that is the radius of this circle, equals to OA, that is also the radius of this circle. But we know that OC equals to X plus 6 units. So we can substitute OC in the first equation by X plus 6 or X plus 6. And we know that OA equals to Y plus 3 units. So we can substitute OA in equation number 1 by Y plus 3 units. Okay? So we substituted OA by Y plus 3 units, and we substituted OC by X plus 6 units. Okay, now we'll subtract 6 from equation number 1. So we subtracted 6 from equation number 1. X plus 6 minus 6 is x, and y plus 3 minus 6 equals to y minus 3. So we get from equation number 1 that x equals to y minus 3. Okay, so actually, because of the fact that this is a square, all the sides in a square equal to each other. So if this side of the square equals to x, then this side also equals to x. So we can write here that line segment NB equals to x. Okay, line segment NB equals to x, because all the sides in a square are equal to each other, and if this side OM equals to x, then this side is also equals to x. But we know from equation number 1 that x equals to y minus 3. So we can write here that x equals to y minus 3. And actually, the radius OA is the radius of this circle, and OA that is the radius of this circle equals to y plus 3. Okay, so I will write it down that OA that equals to the radius of the circle equals to y plus 3. OA, the radius of the circle, equals to y plus 3. Okay, OA, the radius of the circle, equals to r, the radius of the circle, equals to y plus 3. Y plus 3 is equals to OA. But we know that OB is also the radius of this circle. OB is also the radius of this circle, and OA is the radius also. So if the radius OA equals to y plus 3, so the radius OB also equals to y plus 3. The radius OB, or the radius OA of the circle equals to y plus 3. And OB is also the radius of the circle, so it will be also equal to y plus 3. Okay? So, actually, if we look in the right triangle ONB, if we look in the right triangle ONB, first of all, ONB in the green color is a right triangle because of the fact that angle ONB equals to 90 degrees. Why? Because all the angles in a square equals to 90 degrees. And angle ONB is one of the angles in the red square. So it must be equal to 90 degrees. Because of this fact, also triangle ONB in the green color is a right triangle. So in this right triangle, we know that the hypotenuse is the radius of this circle and it equals to y plus 3. One side of this right triangle equals to y and the other side equals to y minus 3. So we actually can implement the Pythagorean theorem in order to find out the value of y. Okay, so actually the Pythagorean theorem states that the square of the hypotenuse, that is to say OB square, equals to the sum of the squares of the perpendiculars, equals to ON square plus BN square. Okay, so in the right triangle OBN, we can implement the Pythagorean theorem that actually states that the square of the hypotenuse, that is to say OB square, equals to the sum of the squares of the perpendiculars, equals to ON square plus BN square, equals to ON square plus NB square. Okay, so but we know that OB equals to y plus 3, so we can substitute OB in the second equation by y plus 3, and we also know that ON equals to y. We can substitute ON in the second equation by y, and we also know that NB equals to y minus 3, so we can substitute NB or BN by y minus 3. So we get that OB square is y plus 3 square equals to ON square. ON is y, so it is y square plus BN square, and BN is y minus 3, so it is y minus 3 square. Okay, so we got in the second equation that y plus 3 square equals to y square plus y minus 3 square. OB equals to y plus 3, so we substituted OB by y plus 3. OB equals to y plus 3. ON equals to y, so instead of ON square we can write y square, and BN equals to y minus 3, so BN square is y minus 3 square. Okay, here in the second equation we will open the brackets in both sides of the equations. So y plus 3 square equals to y square plus 6 plus 6y. Okay, y plus 3 square equals to y square plus 6 plus y, according to the equation, or according to the formula that a plus b square equals to a square plus b square plus 2 times ab. Okay, here we have y minus 3 square, it equals to y square plus 6 minus 6y. Okay, y minus 3 square equals to y square minus plus 6 minus 6y, according to the equation that a minus b square equals to a square plus b square minus 2 times ab. Okay, in the next step we can cancel y square because we have y square in both sides of the equation, so we can cancel y square, and we also can cancel 6 because we have 6 in both sides of the equation. So what left is so in this side of the equation the only expression that left is 6y, and in this side of the equation what is left is y square minus 6y. Okay, now we will subtract 6y from equation number 2. So we subtracted 6y from equation number 2. 6y minus 6y equals to 0, and y square minus 6y minus 6y equals to y square minus 12y. In the next step we will take a common factor y out of equation number 2. Again, we will take a common factor y out of equation number 2. Okay? So here we took a common factor y out of equation number 2. So we got that y, it is y times y minus 12. Okay, actually to this equation we have two solutions. Either y can be equal to 0, but it is impossible. It is impossible that y is 0, because then we don't have at all circle, or the square does not exist. Okay, so it is impossible that y equals to 0, so the other solution is y minus 12 equals to 0. So The other solution is that y minus 12 equals to 0, so here we'll add 12 to this equation and equation number 2, and we will get that y equals to 12 units. Okay? Okay, y equals to 12 units, but we know that the radius of this circle is OB, and OB equals to y plus 3, and y equals to 12. So the radius of this circle is 12 plus 3, that is 15 units. Okay? So I write it down. Actually, the radius of the circle equals to OB, and OB equals to y plus 3, and we found out that y equals to 12, so it is actually 12 plus 3, that is 15 units. Okay. So the radius of this circle is y plus 3, and y equals to 12, so y plus 3 is 12 plus 3, so the radius of this circle is y plus 3, that is 12 plus 3, that is to say the radius of this circle equals to 12 units. Okay, so now I will summarize the lecture. After we wanted to find out the radius of this circle, we defined this point as M and this point as N. We know that MC equals to 6 units and NA equals to 3 units. The center of this circle is at point O. We defined line segment OM as X and line segment ON as Y. And we know that OC is the radius of this circle. So OA is also the radius of this circle. So we can say that OC equals to OA, because both of them are the radiuses of this circle. Okay, but OC equals to x plus 6. OC equals to x plus 6. Okay, OC equals to x plus 6, and OA equals to y plus 3. Okay, OA equals to y plus 3. So x plus 6 equals to y plus 3. We subtracted 6 from equation number 1, and we got that x equals to y minus 3. Okay, x equals to y minus 3. Because of the fact that we have here a square, this is a square, so if this side of the square, if side OM of the square equals to x, then side NB is also equals to x, because all the sides in a square are equal to each other, so this side is also x, but we know that x equals to y plus 3, to y minus 3, so we can write the equality that x equals to y minus 3. This is from equation number 1. So in the right triangle ONB, it is a right triangle because all the angles in a square equals to 90 units, so ONB is an angle of 90 degrees. For this reason, triangle ONB is a right triangle, so the green right triangle we have one side that equals to y, the other side equals to y minus 3, and the hypotenuse of the green right triangle equals to y plus 3, because it is the same radius of OA, and OA equals to y plus 3, so OB, that is also the radius of this circle, also will be equal to y plus 3. So we can use the Pythagorean theorem in order to find out the value of y. And actually, according to the Pythagorean theorem, the square of the hypotenuse, that is to say OB square, equals to the sum of the squares of the perpendiculars, equals to ON square plus BN square, equals to ON square plus BN square. Okay, but we know that OB equals to y plus 3, ON equals to y, and BN that equals to x equals to y minus 3. So we can substitute OB by y plus 3, ON by y, and BN by y minus 3, and we can get that y plus 3 square equals to y square plus y minus 3 square. And after we solve this simple equation, we got that y equals to 12 units. Y equals to 12 units, but the radius equals to y plus 3, so the radius of the circle will be equal to y plus 3, that is to say to 12 plus 3, that is to say to 15 units. So the radius of this circle equals to 15 units. Okay, thank you very much.